Welcome back. In this episode, I will show you how we can take this concept model we have and turn it into a manufactural model. As you can see, we have wood joinery and all the individual building elements blocked out. In addition, I will show you what components are, which you can see here, and then how these components can be used to be sent to the drawing module so we can create technical drawings of our design. And in the drawing environment, we can create cut sections, add dimensions, and as you can see here, even create like a part list, etc. And with all that said, let's do it. So here's our finished concept model. This is still one block, but this actually made this very easy to model. And we can also quite easily select elements, move them around, kind of like when we talk with a client and discuss it. But if we now want to make a physical prototype, this geometry we have isn't very suitable because we would like to separate everything. I will create myself for the moment a folder, and then the drawer goes in there, this stays, and all this I put into this folder too and hide it, so it's gone. Cool. Now here is the carcass. It's kind of morbid, the term frame I like more. And we would like to slice this into the individual building blocks. So I would like to have a side frame, left and right, a bottom, something in the inside, and this top plate. The top plate, this bigger rectangle, this area I would also like to have down here. So check this out. It's another question of how do we split this body, in what sequence. And everything I show you here, while applied to a piece of furniture, applies to every product we can design. Because in consumer electronics, whatever, it's the same. We make a big form and then we start slicing it. So split body. This body I would like to slice along this inner face. That is important. And there you can see, now we have this part separated. Now let's go split body again. This body, split along this or this. So we can also do this with two faces at the same time. Beautiful. Now we have separated the sides. Awesome. This is an insert. So along this plane, we would like to split. So you split along this one. There, done. Look at that. That is how easy it was to create all these individual boards without any additional extra sketching work. Now this can be glued onto here. This can be glued onto there. This one, yeah, when we put something on it, there's a lot of weight on it. It might fall down. So this is not super ideal. So we can select this, right click and say isolate. And then I select the two outer faces. And those I would like to expand by 1/4 inch. Right click, unisolate. And now I can see how far this goes into the volume. Yeah, it's actually pretty good. So then I can go the combine, U, minus U, cut, and keep the red part. So keep tool, think about this red piece as a tool, we keep it. And here you see we cut that groove, no? So let's do the same on the other side. So you combine this one. Actually, I might have to change the sequence there, done. Okay, very good. So this is actually pretty sound, easy to construct. We only want not too complicated wood joinery. Everything here is kind of like basic stock, which we can put onto a table saw and cut, and then we join this all together. Down here, let's do this actually a little bit more refined. So this one I will isolate. There we are. Cool. Then check this out. When I select these two, it tells me lower right corner, half an inch. Okay, so this one I will shrink minus quarter inch. Then the sides, I expand quarter inch. Okay, and I forgot one step, undo. Let's go extrude. We extrude the top face quarter inch to get back to half an inch, but as a new body. There, thank you. And then you and you. We expand. There, check this out. There's a little bit of a step. And now we can say you and you join together. Thank you. And then we can go combine and say, so from this one, I would like this one to be removed. Same deal. Right click, repeat, you from you. Okay, there. Now we can see that this stepping, it's a basic wood joinery technique, is actually more stable. It has 1, 2, 3 faces actually. In different orientations. When we put wood glue in there, clamp this together, this will hold really good. This, because it's a little bit inside, can't fall down. This can simply sit on top. We can just glue this onto these edges. Very good. Now we could select this piece, do an isolate. This is maybe way too big. So minus 0.25. Whoops. This was probably the wrong value, minus 0.25. So we shrink this, make this thinner. It's a back plate. It doesn't have to be as thick. Common element in furniture design. Pieces that need to withstand force are thicker. Pieces which do not can be thinner. Saves money. And then this we expand quarter inch to the sides. No, there you see how this intersects again. Same deal. There, easy peasy. Cool. Yeah, very nice. So if we hide this, there you can see there is the cavity for that space. This detail I put in the back strengthens everything actually pretty good, but also makes the work a little bit more, or the piece a little bit more labor intensive, because now, as you can see here, I have this extra piece of material left over. So with a router, I need to grind out this slot as good as possible. I can't just simply, for example, come from one side and just zoom, cut completely through, because if we would put it all together, well, it would look like this. That's terrible. Okay, goodie. I think you start understanding, kind of like here with the wood joinery, it's a question of stability, question of how easy can each part be made. That's also cost, but also the looks. Now from the back, that's actually quite nice. But then again, this is also a back piece. Doesn't really, do we see this? Probably not necessarily. From the front here, this is all quite nice. We can see these details. Okay, very good. So we have actually this frame that is done. If we want, we can create a folder and, for example, put these in there. Frame there. Very good. And then here is our drawer. I drag this one out. And there we are. It doesn't make any sense at the moment to put such a piece into a folder, because if we start splitting it around, elements will move around too. So here we'll do this very quickly one more time. We need to separate it. So you separate it along this, right click, repeat. You separate it along there, and there. Right click, repeat. This piece separated along there. Thank you. And then actually this bottom part, that one, that I move up 1/4 inch. There. Because now with this board isolated, I can go ahead and select all these vertical faces and expand 1/4 inch. And then, yeah, you guessed it. It's another set of clicks. There we are. Cool. Now, let's select these two, you and you, that one and then one. I press S for the command search bar and then isolate. Oh, it doesn't show it. Okay, never mind. Well, that was in a different program. Okay, right click. Oh, unisolate maybe. They were already isolated. So right click, isolate. Just only this one piece. Okay, we do this one by one then. So you see here, this thing I can just push out and then clean it up this way. Unisolate S and isolate. Yeah, it doesn't give access to it. Right click, isolate. Whoop, that was the wrong body is selected. There. You see there's a dashed line under it. That means this geometry or body is selected. And it's a little bit confusing there right now because these objects are not selected. This time here I used the extrude command to simply extrude cut, clean this up. Good. Now this is a very easy piece. We can just put this on table saw, cut it out, and then with the table saw or a router, we just grind out these details. And then when this is a drawer, yeah, in the end here we can see this, but we don't pull out the drawer as far. We only will see it from here. It's a very basic drawer. It doesn't have any glides. We could then move these sides, for example, inwards a little bit, or put something below, but we just keep it at this where it is right now, since this would be a little bit more extra work. And then all this we can put into here and call this drawer and dissolve. Cool. Nice. You see now we turned this model quite nicely into actually a prototype that is more manufacturable. And everything was just done by taking a concept model and then via direct modeling, we started manipulating, slicing, Boolean commands, removing material, adding material to create the wood joinery. Our next step now would be to create a physical prototype in the woodshop. And to do this, we need to have a construction guideline or a manual. Well, here, this is kind of like the X and Y for the sheet of lumber, which we can cut on the table saw. Yeah, and then here we have, for example, all these edges, which we could take measurements from, and then use this as a guide. How, for example, we can use a router or a CNC machine. And this process is actually super nice in today's time. Before 3D was working this way, you created draftings, 2D drawings front side with everything. And as you can see here already, we started modeling more conceptually and now we're putting the details in. So it's kind of like interestingly reversed. In the past, you made a 2D drawing and a physical model, and now we make a 3D model from which we create drawings to make the prototype. So to create a prototype, we need what is called a component. I will hide all this, and I will hide also this. So we only have these parts. And for example, up here, there is a part, a right-click, new component. And for example, this I can call top. Select this one, right-click, new component. And I'm going to call this bottom. Here, that's the center, right-click, component, center. I just use top, bottom, center based on the position. Now you can also call this A, B, C, D, E, however you want to name it. Here's our back. And there. And then we have left, oops, component, and right. Oh, interesting. It just captures that name. Right. Okay, good. What is interesting with components, by the way, is, so here's a component, and I'm making a copy of this component. Okay. So a component is different than simply a body, because when I select one component and adjust it, you see that the other component, the chairs, the geometry, updates the same way. So also here you see right one, right two. We make another copy there. So the number behind is actually the amount of copies, 3 copies. Right, that's always the same component. So it's kind of like building units, because a table might have 4 times the same leg. We don't have to just create 4 drawings for the leg when it's just essentially one drawing we need, and we just make it 4 times and assemble it correctly. And it helps later also inside the construction system to count everything. It's very useful. So you see, this is kind of like everything we have here. And in this exercise, I will keep this at where we are. The drawer we could set up the same way. Also here, for example, this we only need 1 time, not these other 4 times. So for example, here I would go ahead and say right click, make a drawing. Sorry, a component. So this is, for example, foot. Very good. Thank you. And then this is, let's say, support. Good. The rest I don't need. Because what I will do now is you and you. I will do a circular pattern. So these 2 components along here 4 times sock. Look at this, support 1, 2, 3, foot 2, 3, 4. So everything I have here, these original pieces, actually I can now delete. I don't need this anymore. Very good. Yeah, and then for the drawer I just keep out for the moment. But it would be essentially the same way. We could, however, do one more thing if we want. We can make a new component. Maybe I call this one base to make this easy to see. And then all this goes into the base assembly. So this is now kind of like an assembly with all these parts inside. And new component, frame, and then all this carcass goes into the frame. Cool. I also have these points here. I can this way jump into visibility for one assembly or component, or just go back to the root. There. Cool. Okay. I hope that this basically explained this use of components really well. Also how I swapped parts out. This one and this one, they're not the same because they're mirrored. So I need the left and the right. But these elements are pure copies. So I only made 2 components and then used the circular array, in this case here, to move around. Otherwise, I would have made a copy, rotated it, and then moved it around and aligned it. Okay, good. So, time to go to the drawing. Now to create a drawing, first we want to save this. I created myself also a new version, V2. So my original concept model is a different Fusion file. And now I can go to File and then new drawing from design. There we are. And it's going to ask us, so what do we want to include? Now, for example, I'm going to show everything, these 2 pieces together. Okay. Takes a moment because it's loading the drawing module right now. In case somebody has a good joke to say, this might be the perfect moment to do so. And drums, drums, drums. Fusion is working so hard. There we are. And there's our piece. Now here we can specify, for example, the orientation. Which way would we like to show it? No, it's up to you. And also the scale, maybe 1 to 5. Works good. I click and say okay. Nice. So there I have, for example, all these, everything together at once. One thing I would like to point out, when we save this, and then I go to the design, and here I move this up, and I save. And then I go to drawing. Oh, there's a warning. Aha, something got changed. Click update, and you see it got changed. Pretty cool, no? So you see, once something changes and you save it, between the drawing and the geometry, the drawings are perfectly the same. Cool. So it's a huge relief actually, because you don't need to worry that your drawings are correct. In the past, when we did these draftings, front view and side view independently, you needed to be very, very careful not to make sure that you did not put anywhere an inaccuracy in. Here, the software does it for us, relieves us from that more labor-intensive task, and frees us to do more creative work. Cool. So, we can, for example, add another page. There we are. I would like to bring something in, a base view. Then there's the mid-century part. Now, okay, maybe from the front again. There. Click this one here. Okay. And you see this is a front view. Let's do a projected view, the whole thing from the side. Okay. There. Cool. Now, front view, side view. Very easy. Maybe create a section view would be interesting to see. So where's the midpoint? So from there to there. There's, the section view. Also cool. And it does actually the text and everything for you. AA, the direction, AA, scale 1 to 5. This is all scale 1 to 5 at the bottom. Cool. We can add some basic dimensions. I'm not going to do too much because I think once you understand how this works, this is very self-explanatory what I would like to do is more give everybody in a brief overview, understanding how the system works. Because again, once you understand how this works, it's pretty much everywhere the same. So here I have edges. I can click on these edges and give dimensions. And how you do drawings, make drawings so they're easy to read. Be nice to the person who has later to build something based on these drawings. So for example, the dimensions should be nicely organized. So you see here how I have on this view the total height, height of the carcass, maybe height of the feet, height of this support, and then I start trying to line up all these elements. And maybe this one can go there. Okay, very good. Yeah. We can do maybe one more drawing. There we are. Bring another base view in. 1 to 5 again. There we are. Okay. And this time I just only would like to see the base. And we have this other stuff, the bodies. So I hide the bodies. Very good. So now I have only the base here. Very nice. So what did I do here? You noticed? Look at this. Item 1, foot. Item 2, support. Quantity 4 times. So yeah, you guessed it. This is basically under the table. That's the BOM, bill of materials. If we, for example, add the frame, now we have the frame here at the base. So it breaks it up this way. If I only have this particular single, here maybe the base we turn off. You see now how this updated. This is actually pretty cool. These we can move around these balloons. There. So 2 is bottom. Yep. 6 is right. 5 is left. So pretty nice. Now, so you can see based on what we turn on here, this bill of material parts list changes. If I only have one assembly or a sub-assembly, since this is the full assembly, then we see the individual parts. And if we show both sub-assemblies, then we see more the frame. So just be careful about this. And essentially, there we can break this one out. We could make another drawing and then, for example, put the base on it and so forth. Okay, good. There's obviously a lot more to the drawing, but for the beginning, I would like to keep it at this where it is. So you have an understanding of how we can create the individual views, base view, projected view, section view. Detail view is actually interesting. Wait, how does this one work? Okay, one more time. Detailed view. So from this detail view, there we are. Okay, good. One more time. So I never really did this before. Okay, now I start understanding how this works. Good. So the detail view, the center, so you select the part and then maybe here I zoom in and I say here, this area I would like to highlight, click, and then I can drag this detailed view out and change, for example, the scale. Yeah, Okay, so this is the part, this is the detail. It shows me this. And then we can do the dimensions there. That would be a little bit mean to do because we have to zoom in a lot. So we can then do the dimensions, for example, rather here and adding all the stuff. I'm making this on purpose a little bit messy so you can understand if we do all this in here, this would be a little bit crazy. Now, to bring this to an end, for everybody who bought an IKEA piece, you remember all these assemblies, directions, how everything is being put together. This is a tool you use to create, for example, these drawings, etc. Okay, with that said, that's it.